So in today's experiment, we are going to perform another TLC method. This is the TLC of amino acids. So as in our previous class, already we have prepared the TLC plate. So this is the ready-made TLC plate available here. So you can see here, this is the standard amino acid in solution form. So with the help of the capillary tube, you take little quantity of standard and you put the applied sample here. Now take another capillary tube, and this is the mixture of amino acid. So little quantity of mixture of amino acid you take, and again you put as a drop wise on silica gel. Now wait for some time till it gets dried. So what we have applied here, we have applied a standard amino acid. Here as a standard amino acid we have taken the valine solution, whereas the mixture of amino acid consists of three different amino acids. We have taken arginine, valine and cysteine. So three different amino acids we have taken, and now we are going to compare. Our plate has been dried. Now we are going to place it inside the solvent system. This is called the TLC solvent system chamber. Before keeping the plate, always remember your chamber should always be in saturated condition. Wait, you put all the necessary solvent mixture together and wait for some time so that the entire atmosphere of the solvent system get saturated. Now after saturation, you dip the plate in this fashion. Here as a solvent system, we have taken N-butanol, acetic acid and water, 4:5:1 ratio. So this is the mixture of the solvent here we have taken. Now you wait for some time till it reaches to the solvent front. Here as a solvent front we have already pre-measured 10 centimeter. When the solvent will reach up to 10 centimeter, then we will take out the plate. The solvent will move against the gravitational force due to capillary action. Now after that, after obtaining the necessary 10 centimeter, you take out the plate and you keep it inside the hot air oven. So this is the hot air oven. You keep the slide inside the hot air oven and wait for some time till the plate get dried. So we have already waited for a few time, and let us see what is the condition of the plate. So this is a dried plate. You can see here the dried plate. Now in this dried plate we are going to spray ninhydrine as spraying reagent, because ninhydrine is used as staining agent for most of the amino acid. Now if we spray here, then we can find the violet spot. Here you can find in the standard we can find only single spot, whereas in case of test compound we can find at least 3 spots. Now match the RF value of standard with the RF value of your test sample. Pause. Now the calculation of the RF value. RF value means the retention factor. RF value is calculated by distance travelled by the solute front divided by the distance travelled by the solvent front. Now the solvent front we already measured, it is 10 centimeter. So at the denominator always it will be 10. Now we are going to measure how much it has travelled. You can find here, let us imagine it travels approximately 5.9 centimeter. So 5.9 divided by 10 is equal to 0.59. So it is the standard RF value of this compound we have taken. So the RF value of valine is 0.59. Let us consider about the test. We can find here the test approximately also traveled 0.6 centimeter. So 6 divided by 10 is equal to 0.60. So the other value of the compound present in the test solution is 0.6, which one is matching with the standard valine. From this we can infer that the valine is also present in the test compound. Like that, for identification purpose we can use the TLC technique, and from at least 2 centuries now the TLC is one of the premier technique used for the separation of phytoconstituents.